the rest of today, as well as all the workshops and tutorials tomorrow. And hope you've gotten to enjoy a little bit of Austin. If you've been just too busy in sessions and catching up with colleagues, you have hopefully an opportunity tonight, tomorrow, which is when Austin downtown really starts to heat up. Tonight, usually on Thursdays, Fridays, and Saturdays, they actually block off 6th Street, one block that way, to all vehicular traffic. It becomes a pedestrian-only street around 10:30 p.m. So that's quite a sight to see if you haven't seen it before. And the weather's not perfect, but for those of you who have been the recent GlobeComs, you know this is a lot better than it's been, even including in Miami a few years ago. So, first of all, I'm Jeff Andrews. I'm the technical program co-chair along with Robert Heath, and I just wanted to, on behalf of all the technical program members, thank all the volunteers that helped put this on. Actually, this is my first time chairing this conference and my last time chairing this conference. It was great. You should all do it soon. But it really gave me an appreciation for what a huge effort GlobeComs and ICCs are to put on. I've been coming to them myself for 15 years. And it's really amazing how many people get involved and how our whole community really comes together to bring this conference together with the constituents from every technical community. In the end, we had about 15 workshops, 12 tutorials, 80 technical sessions. I mean, we had over 10,000 reviews for this conference. 10,000 people reviewed papers for the workshops and the technical symposia. It just shows the breadth and depth of effort that's required. So, you're not here to listen to me. You're here to hear two amazing keynotes. We have thought leaders from AT&T and Qualcomm here to talk to you today. So to introduce them, I'm going to welcome to the stage our keynotes chair, Mahmoud the Man Danishman. Where are you, Mahmoud? All right.
Thank you, Jeff, and good morning, everyone. During my AT&T labs, many years, there was a period of 10 years which I was at the AT&T Shannon Labs research, and I was fortunate enough to be a colleague of an outstanding lady who was a researcher, in addition to being a researcher and scientists, leading a team of researchers and doing research herself. She was paying special attention to development of the minorities of women in science and engineering. To me, that was an outstanding effort, even spending time with the high school students for the minority and women. Dr. Alicia Abella is an assistant VP of the research at the AT&T Labs. She has done, in addition to research and publications, she got the Medal of Columbia University Medal of Excellence. It is not very often that one can get Columbia University Medal of Excellence. She was selected by President Obama to be his President Advisory for Women Technology International. For Women Education Excellence. And also she was recognized in Hall of Fame for women technology activities. I don't want to waste your time anymore and my time. We'll get the podium to Dr. Alicia Abella. Please welcome.
Thank you, Mahmoud. Okay, thank you. Very good. Well, good morning. Thank you. I want to start off by thanking the IEEE committee and the chair for inviting me to be here with all of you today and to speak to you on a topic that is quite hot right now in the industry on cloud computing. If you look at the literature for cloud computing, you'll find that cloud computing was first uttered publicly in 2006. which is not that long ago. It's approaching its 10th birthday, not quite there yet, but almost. And despite it being an area of technology, it's still very much in its infancy, even though technology tends to evolve very rapidly. In this case, we're still in a bit of a green field of cloud. And so I thought when I was invited to speak here today that I'd speak about cloud computing, but give it a little bit of a twist. And talk to you today about how, because cloud computing has been called a disruptive technology, how I can maybe draw parallels between cloud computing and other disruptive undertakings and activities that have had major global and economic impact. And see if we might not be able to learn a little bit from history as we walk through some of what is evolving in cloud computing. So, as with every disruptive technology or disruptive undertaking, there are those who embrace it, who will take risks to make sure that it gets done. And then there are those who are afraid of it. They fear change. They are the naysayers. And that's the same for cloud computing. There is definitely a fear of the cloud. And some of that fear is justifiable. If I am a small business owner or a medium-sized business owner, I'm being told that I can move all my services and applications into the cloud, out there, somewhere. And I think, okay, why would I want to do such a thing? And then they keep talking to me about why it's important to move into the cloud, and they start to go through all this terminology. And the terminology alone is daunting when you start looking and investigating what it is about cloud computing. You know, you have things like hypervisors, elasticity, multi-tenant. You know, hypervisor, well, I know what a visor is, right? If I'm a small business owner, yeah, visor, it protects my eyes against the sun. Yeah, or maybe it protects my dashboard, car dashboard, from melting in the sun. I know what that is, yeah. Elasticity, I know what that is, right? That's about when an object stretches and then returns to its normal form. Yeah, I know that. That's elasticity, right? Multi-tenant, well, I'm from New York. Multi-tenant to me means a building with multiple families living in it, right? That's what multi-tenant is, right? No, that's not what this is. Then you've got the acronyms. And this, I mean, we can go pages and pages to discuss the acronyms associated with cloud. I worked for the NSA for a little while, so I know about acronyms. And I think cloud computing is giving the government a run for its money in terms of acronyms. And then what up with everything being open? OpenStack, OpenShift, Open vSwitch, Open Daylight, Open Flow, right? Everything's open. What does it all mean? And as if that weren't enough, it seems that every noun and verb in the English language is being preceded by the word cloud. Cloud provider, cloud broker, cloud storage, cloud sourcing, cloud where, cloud washing. And even my favorite, cloud envy. Even my team didn't know what that was. And they live and breathe cloud every day. So for a change, I was able to actually teach them something. So you can ask me later what cloud envy is. Now, in all seriousness, terminology can be memorized, terminology can be learned. You can look it up in the dictionary, do a Google search, and you'll find out what Google envy is. But the truth is that the real fear in moving into the cloud is loss of control. So as a business owner, as somebody who owns IT responsibilities, I'm now being told that if I move to the cloud, I'm going to get all these benefits from moving to the cloud. But I'm also losing control. I'm losing control of that nice, protected infrastructure, private cloud that I've developed, that I've tested, that I've designed, that I have people there to manage and maintain. But now when I move into the public cloud, I fear that I'm going to lose security of my applications and services. And that if my applications and services are running in the cloud, and now you're telling me that not only are they going to run on the public cloud, but they're going to run in a multi-tenant environment, which means that I'm going to have other applications and services running on that same infrastructure alongside my services and applications. So how do I guarantee security in that environment? And then on top of that, I have my data that's out there as well. So how do I protect the data, and how is that protected? How about data loss? If I'm commingling services and applications, how are you going to guarantee that I'm not going to lose data? And then again, I'm running on a shared infrastructure. What about the performance of my services and applications? How are you going to isolate the performance of my applications and services so that they don't get interfered with by other applications and services? And likewise, the reliability of my applications and services. And then I also hear that, well, if I move to the cloud, I'm going to gain cloud cost economics, right? I'm going to be able to save money by moving into this public cloud, because now I don't have the costs associated with managing my own infrastructure. But is that real? Is that cost savings real? There's a balance and a trade-off that I'm doing now, because I'm worried now about the security and data loss and protection of my services and applications and performance isolation. So is it true that I'm going to really get a big bang for my money if I go to the cloud? And so this is some of the fear. Now, Tuesday, Ed Amoroso gave a keynote here as well, and he spoke about some of the techniques and innovations that are going on with regards to security in the cloud. So there is definitely movement in developing technologies and innovations for doing this kind of work, to protect the security, to protect the data. My group is working, and my group is a research organization for AT&T that's focused on cloud technologies. We're looking at the performance isolation and reliability issues associated with cloud. And I'll guarantee you that we have techniques that will do performance isolation and reliability in this multi-tenant environment. And that work program we call Cloud QoS. So I am also contributing to that list of terminology. Cloud QoS, quality of service. And what this program is looking at is to be able to, in this multi-tenancy environment, in this shared infrastructure, be able to guarantee non-functional requirements in the cloud. Non-functional requirements being security, reliability, latency. These are all of the requirements that we want to ensure that when we move into the cloud, whether it's services or network functions, that when we do so, we will be able to guarantee the quality of service that all our customers have been used to having in the traditional pre-cloud days. Now, that doesn't come without its technical challenges, which is great, because that's what my team just loves to be able to wrap their heads around, is how do you do that in this new cloud environment? And I'll give you some examples of specifics of what we're doing in just a little bit. Okay, so I think we've talked enough about fear. I'd like now to talk about love. Love of the cloud, that is. There are many reasons to love the cloud. And there are, scalability is one reason to love the cloud. When I move my applications and services into the cloud itself and that infrastructure provides the features for scalability. So as the demand for my applications and services increases, the cloud environment can manage and keep up with the demands. So I can perform scalability in a very quick, flexible, efficient way. It takes a lot longer to do it in the traditional pre-cloud method of doing it. So that means my time to market is accelerated. I can much more quickly deploy my applications and my services in this new cloud environment. I don't have to now spend time, say as a developer, worrying about testing and designing and buying equipment and setting it up and configuring it and provisioning it in order to ensure that I have the necessary infrastructure for my applications and services. I can go to my cloud provider and say, this is what I need, and it gets stood up. So my time to market is is improved. The cost efficiencies are also quite obvious. So again, I don't have to have an organization that is devoted to buying and provisioning all of this equipment and maintaining it, upgrading it, making sure that everything is compatible in terms of all its releases for the software. I can now put that burden on the provider of cloud. So there's cost efficiencies associated with that. Not to mention also the fact that I now don't have to manage my own data center where I have to take up floor space and energy to cool these facilities. I let now the cloud provider do that. Now, as a cloud provider, I get benefit from the cloud because of this notion of multi-tenancy. Multi-tenancy is where a lot of the cost efficiencies and operational efficiencies of cloud are going to come from. The ability to take that infrastructure that I've stood up and be able to commingle applications and services on that infrastructure. And the reason why that's going to give us the cost efficiencies in cloud is because a lot of the time, the way I'll go back to the sort of traditional pre-cloud days. You have an application and a service, you buy all the machines you need, all the boxes, you set them all up, and you make sure that you over-engineer your problem. Right? You over-engineer for the worst case scenario. So take as an example that the service that I have is an audio conferencing service. And I know from the usage of that conferencing that 11 a.m. Eastern Time and 2 p.m. Eastern Time are my peak hours for conferencing. That's when I'm going to get the biggest load on that infrastructure. So I got to make sure I have enough boxes ready to be able to handle the load at 11 a.m. and 2 p.m. Which means that at 1 a.m., those machines are going to be sitting there idle. Right? They're not going to be running. They're going to be taking up space. They're not being utilized. So I have underutilization because I've had to over-engineer the problem and make sure I have enough boxes. Multi-tenancy allows me to take advantage of the fact that I have that infrastructure sitting there at 1 o'clock in the morning, not devoted to conferencing, but maybe I can devote it to something else. I can devote it to a big data job, a Hadoop job. Some other application or service may want to run at 1 a.m., especially if it's not 1 a.m. at some other part of the country. And I'll get back to that in a second. So the other thing that leads, so multi-tenancy is one of those things that's going to lead to, as a provider, operational efficiencies. The other that's going to provide operational efficiency is that notion of elasticity. Now, elasticity in the cloud world means the ability to sort of spin up the resources I need to deliver that application, that service, when I need it, and tear those resources down when I don't. So again, this is a way that as a cloud provider, I can gain operational efficiencies because I will only use the machines that I need when I need them to serve the application and service. So as a user, scalability, time to market, cost efficiencies are why we love the cloud. As a cloud provider, multi-tenancy and elasticity are examples of how we gain operational efficiencies. So I promised I'd give you a little bit of some of the techniques that we're working on. So that's what I'm going to do next. So we talked about performance isolation being one of those fears of people not wanting to move into the cloud. So these first three items I have listed here are examples of how we're approaching the problem of performance isolation. It's called network bandwidth reservation, CPU reservation, and I/O throughput reservation. So let me give you an example. When we first started on our transformation at AT&T of moving from a world of customized hardware and moving everything into software and going the route of software-defined network, my group decided that we better be looking at networking in the cloud as one of those challenges that we should face. And we decided to take, as an example, to kind of drive the work, audio conferencing. Audio conferencing we chose in addition to knowing it and having services and applications for audio conferencing as a company, we chose it because audio conferencing has what we call high quality of service requirements, very strict quality of service requirements. It has to be high bandwidth, low latency, and secure, reliable. They're very, very strict requirements. You have that phone call, you don't want those packets dropped because then the voice quality degrades, and basically your call becomes inoperable, right? You don't want to have that conversation, you hang up and you try calling again. Now, this would not happen in sort of your traditional pre-cloud environment where you have over-engineered your problem so that at 11 a.m. Eastern Time and 2 p.m. Eastern Time, you're going to have enough compute power to make sure that this doesn't happen, that you don't drop calls. Now, in a cloud environment and in this multi-tenancy environment that we're in, I have other applications and services that are running on the same infrastructure as this conferencing service. So I have to be able to allow that application service to define the requirements, to allow it to have the network bandwidth it needs when it needs it, and to spin up the necessary resources it needs when it needs it. And so we developed and built some software that will allow an application to define its quality of service requirements and then be able to, when the time comes, reserve the network bandwidth it needs to be able to have that flawless voice quality that everybody's used to in the pre-cloud days. So we did this experiment in this demonstration for audio conferencing, but we also had to, of course, commingle it with other applications. So we chose to have a conferencing service running and also to have a big data Hadoop job running. But that wasn't enough to be able to really stretch the demonstration system that we built. So we also developed a load generator, just something that would generate load on that infrastructure. And we let it loose. And we started to simulate calls, conferencing calls into the demonstration system. And we watched as the system started to run hot, because that's really what we're trying to achieve, right? We want to run that infrastructure really hot so that we can run multiple applications and services and get those operational efficiencies that I talked about. And so you could see how the system suddenly had to give more of its network bandwidth to the conferencing application and, in a sense, take away from the big data job, which was okay, because the big data job had very loose requirements. As long as it finished by the end of the day, it was okay. And so our system can automatically optimize its resources for that, knowing that at this moment in time, I need to give my network bandwidth to conferencing. I'll get back to the big data job as soon as I'm done with this. And that all gets automatically done. And that's the beauty of being able to do this kind of work for being able to perform that performance isolation. So we start to peel back the fear of the cloud, the fear for performance isolation. For next year, my team is going to focus on CPU reservation and I/O throughput reservation as well, since these are also very important as you start moving your applications and services into the cloud. Resource placement. This is when I can address the fear of reliability. So we had that as one of the fears. Resource placement deals with being able to optimally place my resources where I need it in order to guarantee, again, those quality of service requirements. So going back again to the conferencing application, if my conferencing is taking place on the East Coast, I probably don't want those resources that are serving up that conferencing application to be on the West Coast, because that's just going to introduce latency that I don't need. But I can imagine, again, in this cloud environment where things are elastic and things can be moved around, virtual machines can be migrated from one data center to another, I can now follow the sun. So when my calls are taking place on the East Coast, I can move my resources that are being able to deliver that service on the East Coast. And as the sun moves, I can move it over to the West Coast or across the globe, because we are a global company, so we have data centers across the globe. And this again leads to operational efficiencies. This is how we also can gain reliability, because now I know I can meet my quality of service requirements because I'm closer to where I'm delivering the service. Then there is the ability to maximally utilize my resources. And I already touched upon that when I talked about commingling of services and multi-tenancy. I want to be able to use that infrastructure and run it hot so that I can maximally utilize it and get as much out of it as possible so that machines don't sit idle, because I want to be able to use them. So really, just to summarize this piece, the whole transformation that AT&T is doing to the software-defined network really, at its core, is this notion of a shared infrastructure. A shared infrastructure that is dynamic and elastic, because that's how we're going to be able to deliver and guarantee quality of service, the quality of service that our customers are used to having, and to also be able to meet the network demands of our network functions. So it's not just that our services are going to be moving to the cloud, but we've made a commitment to also move a lot of our network functions into the cloud. So now, those network functions, unlike some of the traditional services that have been running in the cloud, they have really strict requirements. I mean, the requirements are quite daunting because they are high bandwidth, low latency, must be secure, and so they really bring requirements that, unlike some of the other traditional services that have been running in the cloud, for example, web services or emails, right? You click on a website to complete a transaction, it's okay if it takes a second or two to actually complete. But again, going back to conferencing, if you're on a phone call and you start dropping packets, that quality is going to degrade to the point where you're not going to be happy. And so we need to make sure that that voice quality is flawless in a cloud environment, just as it is in the pre-cloud environment. So network functions are very daunting. You think about video, too. You know, we're moving a lot into the realm of video. Well, you start dropping packets, and that video gets jitter, and it becomes also unwatchable. So network functions are giving us extra challenges. As if we didn't have enough, we're going to have more in the future. Okay, so that's a little bit about fear and a little bit about love. Now let's talk about disruption. So I mentioned that cloud is a disruptive technology, and I promised that I would give you a little bit of a journey through other historically disruptive technologies. So I want to start with the interstate highway system. The interstate highway system was authorized, and so I'm going to give you a little history lesson here, right? Was authorized in 1956, and it took 35 years to complete, and it had a price tag larger than any other transport project on the planet to date. The interstate highway system of the United States. The interstate highway system had very high standards. There were lots of standards that were defined around the interstate highway system. There had to be at least 4 lanes built, 2 in each direction. The grade of the curves had to be such that it would facilitate high-speed velocities. The hills of these highway systems had to be such that it would not produce any blind spots. Really fascinating stuff as I was reading about it, the interstate highway system. Then there was all the numbering, the standardization of the numbers going north and south and east and west, and quite interesting. Then there was also this notion of being able to also deliver high occupancy vehicle lanes. So that was a new way to improve the efficiencies of the highways, right, is these high occupancy vehicle lanes. Turns out that the interstate highway system had a return on investment that is just amazing. So you get $6 for every $1 it cost, right? Because it improved the efficiency of travel on the highways. It made it possible to start traveling and transporting cargo much more rapidly. It was very efficient. Without the interstate highway system, the American life would probably be riskier and less prosperous. Now, back to the HOV lanes. So I'm originally from New York. I live in New Jersey, which means I go to New York a lot, which means that I've sat there in the Lincoln Tunnel watching at rush hour as buses go by. Right? Bus after bus after bus passing me as I go by, right? But these buses are carrying a lot of people. And in fact, the interstate highway system, and especially because of the HOV lanes, can transport 7 times more people on them than any mass transit system in the country, with the exception of New York City. But that's a lot. That's an incredible efficiency because of it. Now, yeah, I'm telling you all this because I just told you about cloud and being able to deliver on the requirements of services and applications. So when I think about it, I said, well, that bus is like my audio conference, right? I need it to go through, and I want to make sure that it has the necessary capacity to be able to go through smoothly. I don't want to drop packets as I'm going through. So there is a parallel there. The next disruptive undertaking that I wanted to mention is the intermodal containers. Intermodal containers. This was, to me, also quite fascinating. Right? You have these containers that were standardized in order to carry cargo and contents from ship to rail to truck without ever having to unload these containers. I have a friend who worked for the British Navy pre-container days. And he told me, he says he used to be on those ships, he'd dock at port, and they would dock for a week loading the cargo onto the ship, a week of doing this. And so the men on the dock would take all the individual packages and bundles and toss it into a net, and that net would be carried off onto the ship where another group of men was waiting to take all that cargo and put it somewhere on the ship. A week. With containers, that week has now turned into hours. So the efficiency that we just got from standardizing containers, not to mention the fact that now you can track them and you can have sensors in them that tell you the quality of your cargo, especially if it's something that needs to be refrigerated. We've been transporting cargo since the Venetian times. But now there's this way of quickly and efficiently being able to transport it from ship to rail to truck. Now, we'll have to consider what to do now when we start going to Mars. That'll have to create a whole new set of standards for being able to load cargo. So, from a cloud perspective, we're seeing the trends towards standardization as well. So, we are seeing, for example, as a developer, I have the image of my application that I've created, and I can take that image and I can migrate it from my development infrastructure now to a test environment, to a production environment without having to modify or touch it because the image and that infrastructure has been standardized. So I can now fit my application to that container, which is my infrastructure. And that also helps to improve and create efficiencies. I'm also seeing how in the open source community, and OpenStack in particular, they're developing APIs that allow OpenStack to talk to AWS, right? The Amazon Web Services. You're thinking, well, what does that give me? Well, it means that any application that is running on Amazon now, I can move it over to OpenStack, and it'll run there. So there is definitely a trend and a movement to standardization. We're not there yet. I can't yet go from a Maersk ship to any ship, but it's getting there through standardizations. My last example here is the shipping industry. Right? When you think about shipping, the shipping industry being UPS, FedEx, DHL, how that industry got started. There was a time when a business needed to ship cargo or its contents, its materials, its goods that it was selling. It had its own shipping department. Every company had its own shipping department. But little by little, it was, with the efficiencies of the highway and containers and everything moving fast and having easier access and people demanding more goods, the shipping companies came up. And now they're on the transportation index alongside United Airlines and American Airlines. And now I don't have the need anymore as a business to have a shipping department. I just go to DHL or FedEx and they'll ship my goods for me. IT is going through that same process now. You can think of that chicken as IT. Right? And businesses have huge IT departments, but those are starting to shrink. And the need to have big IT departments is going away because we're moving a lot of that functionality to cloud providers and to the whole ecosystem of cloud technologies and cloud providers that are starting to emerge. Now, those little birds, I like to think of them as clouds. So the clouds are coming out of the hen, right? Mother hen, the mothership. Now, there are two there, right? Because what I'm seeing are two models of cloud. There is the model of cloud that is that more the pioneers to cloud, the web services, the email clients, those more traditional applications and services. And then there's the other cloud model, which is the one that network providers are starting to develop to. Right? So network providers, as I mentioned earlier, have their own set of requirements. And they will bring a new cloud model to the ring. So we're seeing that emergence. So in conclusion, and in summary, I would say that although cloud computing is still developing and evolving, I hope that you've been able today to appreciate the fact that there are a lot of gains that have been made, innovations, techniques that are being developed to help peel away that fear of the cloud so that what we have in the end is a blue sky full of white fluffy clouds. And I thank you all for your time today. I tried to get that Photoshop to put my face on that woman's picture, but didn't quite make it.
So we have time for a few questions.
Can you talk a little bit about the impact of video on your infrastructure, computing resources, bandwidth, and how are you addressing that for AT&T?
Yes, so the question for the folks in the back is how are we addressing video and the demands of video in our network? So, I mean, that's one of the examples that I gave, right? Video is one of those examples of applications and services that are going to have these kinds of daunting requirements. And so just like the way we did it for audio conferencing, where I will enable an infrastructure that can take in service requirements, the requirements associated with delivering those kind of quality of service requirements for that application and that service. I take those requirements, and my infrastructure will be able to guarantee you that that video is going to be the kind of quality that you need for your application by being able to do that resource placement properly, to be able to do the network bandwidth reservation that I need, to be able to have the kind of I/O throughput reservation I need, the CPU reservation I need, and you have to do it.
Time for another question? Front row, Brian?
Yeah, can you expand on this question regarding 4K content and its impact? Seven times the file size of 1080p. Can you talk about 4K content and its anticipated impact as people start streaming that onto their systems and homes? Thanks.
So I'm not the best qualified person to talk about that specific question, I'm afraid. But if you reach out to me, I could probably put you in touch with the folks who are working that problem.
And transcoding to the equation into that 4K and being able to repurpose the content for mobile devices as well.
Well, yeah, so certainly we have to be worrying about, so I have another group of folks that are working on machine-to-machine, Internet of Things, and looking at devices and how they're going to, the explosion of a lot of these devices, what are the requirements that that's going to bring to the cloud? Because that's also a very different model. It's not like their client-server model. You now have, many, many devices trying to reach one server, your one infrastructure, your one data center. How is that going to look? We're not there yet with that one.
Hey, thank you very much. Fantastic
All right,
talk, really.
Thank you. Oh, okay. All right.
We have a plaque and appreciation for a really wonderful and visual keynote speech.
Thank you.
Dr. Abella.
Thank you very much. Let's take a picture. All right. Thank you very much.
Thank you very much. Really nice talk.
Thank you.
Okay, I'd like to bring up Mahmoud again to introduce our second keynote speaker.